So let's welcome our next moderator, Heidi Reiman from CSC Finland. And she will moderate the session, New Developments in HPC Interfaces and User Support Services. Welcome.
Okay. Thank you, Eva. So without further talks, I would like to invite our first speaker, Eske Christiansen from DIKE, Denmark, with the topic Cotainr. Eske is the head of HPC at DIKE and is responsible for developing and coordinating the Danish effort in the national and international HPC.
Okay, thank you. Thank you for hosting me. I will talk a bit about a tool we have developed. It was original a tool that we start thinking about in the first installment of UCC, and then moved out of UCC because we want to develop it even further and make it not a product, but a tool that everybody can use. And we will use LUMI as an example for this. And again, as consortium member, we will talk a lot about LUMI, and that is fine. But first, what is DIKE? And I think some of you know it, but others do not. We are a collaboration between all the Danish universities and our ministry. We are building a national research infrastructure on HPC, network, the NREN, the quantum computing, and also on data management and data management service like storage and repositories and stuff like that. One of the targets we have for Elite for HPC is to make access easier for everybody. So, as I talked about before, we have a high number of social science and humanities using our system along with the normal STEM research areas. And we can see more coming. It's like in the Game of Thrones where winter is always coming, we can see more users are coming in, and that is good, but it also makes some challenging problems for us to solve. At HPC and DIKE, we try to bridge the gap between our local installations, our national installation, and also the European HPC resources. So that is very important that we see this as a user journey where users normally start local, go for the national, and then we push them out into the EuroHPC resources out there. One of the other things that we try to do is that we are trying, and the Cotainr tool is a solution for that we try to enable the users to do what they are good at, and that is science. They are not good at optimizing the last 2% of the machine. That is for expert in hardware and software infrastructure people to do that. So that is one key, very important thing for us. And also just to mention that keep an eye on our job posting. We are often looking for new talent, especially in the HPC. So, how do we see, at least in DIKE, how do we see the user journey for HPC users? Normally, we see them starting at their laptop, doing the initial research and trying to figure out what to do with the data. Then they can move to a workstation or single virtual machine in the cloud service, then move to a node using a single GPU, maybe scale up in the next part for a single node with multiple GPUs, and in the last step on the way is to multiple nodes on multiple GPUs. That is a spelling error. Multiple GPUs on a supercomputing. That is what we see as a journey. But the real problem is, as you can see below, how do we support reproducible software environments through that journey? How can we enforce, or how can we ensure that the user has the same software environment for all this? So, ideally, computer experiments, as in the lab, should be reproducible, and so we should be able to rerun the same experiment with again and again and have the same result. Also, one of the things is that it needs to be portable, that we can move the experiment from one computer to another and see that we can reproduce the same results on different computers, and that is basically good science to ensure that. So, containers is one way to do that. Containers has existed in 40 years or something else. And this is one way of separating the responsibility or the concerns of how to split up the system. At the bottom, you can see we have the host libraries. This is what we can call a trusted compute base, that we actually trust that the software running on the system is good, that the drivers there from the manufacturers are not doing evil things with our software or code. Then we have the system-specific libraries, and that where we depend on the user support systems, where they enable things that are needed. That could be system libraries for OpenMPI, EPICURE, other drivers. And then we, at the top layer, has the application libraries that the user control by themselves. So, Cotainr and is a tool that makes it easy to build these kind of containers. And at the moment, we are focusing on singularity containers. It is run entirely in user space, no need for any root or anything else. At the moment, we support primarily Python environments by the Conda and the pip package managers. So if you are mostly AI and machine learning, you're mostly doing your work in Python and using PyTorch and stuff like that. And you probably know the environment of using Conda. You create your package list, and then it's pretty much the same as building a container by container. You just apply your UML file to create it. So how does this UML file look like? For LUMI, this could be the one you have in the middle there. It could be a simple description of what kind of dependencies we have. And it's not much. And then you have a complete environment for running PyTorch. You maybe need some more things for your experiment, but that is okay. And on the left, you can see how easy it is on the LUMI system to actually build a container like this. You load the module, you build the container, and you can actually see that you have everything inside it by just checking some Python code. And now you're ready to submit it, and you are, good to run. As you can see here, we have the system flag for the container, and this is where we see Cotainr evolve, because we want to make sure that we can support multiple systems down the road. We have support for LUMI G and LUMI C, and what we want to see is also maybe have a system where it's Leonardo or Neonomstrom or Vega or something else. So for the future of Cotainr, we will like to make it available for all European JU supercomputers by providing some kind of base images and work with the facilities on actually getting support for this. We want to support the typical use cases for the European supercomputers, like easy building, but also for other than Python. We want to enable R, the computing language R, but also looking at general spec user space environment. And one of the things that we can see on LUMI is that we will look into how we can make use of the open demand with the Cotainr tool to create easy apps for the users to reuse again and run like in an active mode, where user can just have a container, log into on demand, spin it up, run a few experiments, shut it down again, and then come back when they are wiser on their research. So, a bit of links. It's completely open source. It's based on the European open source license. We have a documentation, and we accept changes and everything. And please contact us and work with us on trying to make it better. We think it is a good tool that will enable a lot of researchers doing what they really want to do, research, and not figure out how the system works. Yeah, with that, thank you. Any questions?
Thank you for this interesting information. My question about C++, if I am using for MPI C++, how easily to repeat what you did with Python?
For this easy, but we have seen die-hard physicists at some of our universities that swear a year ago, 2 years ago, that they will never shift from C++. They have shifted over to using Python as a scripting tool and then enable and calling underlying high-performance libraries in that way. So they are more or less stitching their old code base and going over to using Python as a tool of scripting their research. They have a higher turnaround time in actually refitting the research in this way instead of having to change a large code base and very complicated code. But in the end, they are then losing the last 5% of performance, but that is okay if they are still having their research done in some. In my opinion, others will have another opinion.
In case no, thank you, Eske. And then I would like to invite our next speaker, Johan Kristiansson from RISE Sweden, with the topic ColonyOS. Johan is a senior researcher at RISE and has over 20 years of experience in distributed systems, software engineering and machine learning.
Okay, hi, my name is Johan Kristiansson and I'm going to talk about ColonyOS, which is a meta operating system that can be used to combine cloud and HPC. And so I'm working at RISE, but I'm also working at NCC Sweden, where and we are working to get more HPC users by trying to find companies and public agencies and universities that can use HPC. So we believe this ColonyOS can be used to sort of make it easier for these newcomers to use HPC, to kind of breach some of the gaps. And so some of the, I will just say that my background is not really from HPC. I've been working the last year with HPC, so I'm really coming from the cloud. And if there are some challenges, if you look at it from a cloud perspective, you have to use from being a cloud user, you have to use a shell and you have to set up tunnels, you have to do Slurm, and you have to deal with a different HPC system, dealing with data and so on. And there is very few possibilities to use API and automation tools. But I would like just make some quick comparison. So what I think is the difference between cloud and HPC. So if you're working with cloud, really what you want to do is deliver something really quickly to a customer so you can create some value very quickly. And you want to in order to do that, you typically use automation tools. There is a massive use of automation tools. And you also want to have repeatable workflows. If you run something and you run it the next time, you want to have the same result. And for that reason, containers are used everywhere. And Kubernetes is really the de facto kind of container engine that everyone is using. And you also expect this system to be operational 24/7 with very little kind of downtime. And then you have HPC, which is more research-oriented. You want to run a simulation, you want to get some experimental result, and you want to do that as quickly as possible. And it's more kind of exploratory. You don't really know how this pipeline or workflow should look like until you iterate and then you change. So why would you ever kind of automate something you only want to run once? And so there is a big difference. The thing is, if you're working with HPC and then you're starting using a cloud platform, you won't like it that much because this cloud platform, there has a lot of features that you have to work with. And that feature doesn't necessarily bring some value from a research point of view, being a researcher. And also, if you're a cloud, then you will find it kind of, well, it's too traditional. It's too manual. It's a kind of mentality difference. So So what about if we can make HPC more cloud friendly for the cloud users, so that they can so even if you get access to your HPC system for free, it's not really free. You have to spend time porting software. You have to you have to develop. There's a development cost. So what about we can reduce that cost to 0 to make it very easy to use an HPC system coming from the cloud. And when you're running out of CPU hours, then you can switch back to a cloud platform. And also, if you're an HPC user, how can we make the cloud easier to use? I think if you're working with traditional HPC, I think many people can benefit of having better automation tools. So how can we create this HPC cloud? I call it a continuum. And ColonyOS it's a meta operating system. It's an open source project I've been working on for some years that can really achieve this convergence of these two environments. And so a meta operating system, it's kind of something that sits between the infrastructure and the application. It decouples application from the infrastructure. So it creates a unified and consistent interface that works across different platforms. So there are some benefits with this. First of all, you don't have to know the specifics of a platform. You can just use it. Secondly, you get portable workflows. You can run something on the cloud, and then you can run it on the HPC system, and also on edge servers, an edge cluster. So you have you also have efficiency. You can start. I'm working on another project that we try to maximize the use of renewable energy by sort of mixing different platforms and taking advantage of green energy. But I also say one of the benefits of this is resilience, because if you start using one application, one platform, and then there is some problem, then you can switch to another platform. So it gives you flexibility. So there are two use cases that I'm particularly interested in, and the first one is how you can write distributed AI applications. And if you write a such application, you have to deal with training models. You need to constantly retrain the models. So this could be a large language model. It can be like an image analysis platform. But you also want to run in inference on the same on this to predict something. But you want to have a cohesive application, not two different architecture, just one architecture. And this is what a meta OS can bring. And then we have the second thing that if you're an AI researcher, you're working with developing new models. So, I mean, as the previous speaker said, it's typically start working with a laptop. But if you have this kind of environment, you can easily, then maybe next step would be like a gaming machine or a workstation, and then you can, or a cloud platform, and then you can just bring in an HPC system into this seamlessly. So that is also something I'm working on. We are working on. So this is a little bit more technical slide, how it works. So we have executors. They run on like an HPC system. This works on Leonardo and LUMI already. And if you're running on a cloud, you typically run this on Kubernetes in a pod. And these executors, they connect to a Colony server running in the cloud. And then we have the users. They submit a meta specification of computation they want to run, and these are later assigned to one of the executors. So this resembles very much a traditional grid platform, as you can see, but it's a more, you can say this is a modern take on grid computing, if you like. So another concept of this is security. If you can do it in two ways. You can start adding a lot of feature, and then you try to add the security later on. Or you can do it starting with security, and then you add feature on top of that. So that is how Colony is kind of was developed. So I started really with, I was previously working with blockchains, and so I really picked the crypto from a blockchain, and then so that was really the first code I was working on. Then I have built on top of that. But the concept is like this: you have it's called a colony, and a colony is like a collection of executors that reside on different platforms. And a colony is like a bee colony, a honeybee colony, or like an ant colony. It's like a society. So So in order to interact with other executors, or a colony, you have to be a member of that colony. And if you're using this today with a EuroHPC system, typically there is one colony per user. So you start using this, and then you connect to, for example, Leonardo, and then you can write application on top of this. So another thing that I can mention is a tool. It's called Pollinator, and it's really about the second use case here, where we can really easily use an HPC system, but without knowing Slurm. You don't need to know Kubernetes either. So a Pollinator, it takes care of synchronizing data to an HPC system, it takes care of converting containers so it can run, and it's also bringing the result back from an HPC system. And this is my it was not the last slide. So I can also mention that this is also used commercially by a startup that I have been working at. So it's used for processing seismicity in LKB. It's a mining company, one of the biggest mining company in the world. So some parts of this are very mature, but other parts of it is more experimental. So this is my last slide. I think that there will be an unprecedented growth in AI the coming years. And so we have seen generative AI, large language model, and this will continue. And there will be an unprecedented growth also for need for compute capacity. And I think this next generation AI will benefit tremendously by being able to run across different platforms, not only on one platform. So ColonyOS, a meta operating system is a technology that can be used to create these continuums by combining different platforms. And so ColonyOS requires minimal changes. You can use this already today on a EuroHPC system or Kubernetes system. So I asked ChatGPT to generate how a compute continuum could look like, and it generated this kind of scary picture. But at least it was a good visualization of what I think a continuum can look like in the future. So if you want to know more, just reach out to me, and I can make a demonstration, or I can explain more how it works. Okay, thank you.
Thank you, Johan. Is this microphone on? No. Okay, so is it on now? No? Yes. Thank you, Johan. So do we have any questions from the audience?
I just have a quick one, Ilja from University of Tartu. When you execute something on LUMI, or generally speaking HPC, I think you mentioned that it's like efficient in that sense that it's only executed once it's needed. Mm-hmm. But what about this executor itself? Is it like a service running next to the HPC system, or what is the context or under which user it runs? Or
I mean, it runs. So when I run this today on LUMI, for example, or Leonardo, then I will log into one of the login nodes, and then I will start this process, and it runs in the background. But there are some problems with that because you have multi-factor authentication. So you have to restart it all the time. And I also learned that it's not perhaps the best place to run this kind of software. So.
Okay, so it's to some extent like your user.
It runs in the user space completely. So
okay,
so it doesn't require any kind of firewall configuration. It just connects to the internet. And
okay, thanks.
Yeah.
More questions?
If you have to do that as a user, isn't this simplicity you talk about gone? If the user first have to log into the machine, start the executor, and then, so to say, then they have a simple process. So this must be just a temporary solution just for you to get things going. And
yeah.
when we install this on the, if you're really going to work with the system, we need to have that executor as part of the, or some executor node or so, or server in the system that actually can take this role for all users, I guess. That's
So if I could wish for something,
Yeah.
I would really wish to have a Kubernetes cluster side by side to the Kubernetes or Slurm cluster, so you can run deploy services on this and that cluster, and then it can interact with.
Okay,
Slurm. That would be nice. But right now I'm just showing the potential of this. And then
okay, but what you're asking for that we can arrange, so that we have it. So that's can be done, I think. So.
Yeah.
Okay. Thank you.
Thank you.
More questions? Okay, if not, then thank you, Johan.
Thank you.
And next I'd like to welcome Ilja Livenson. I don't know if I'm pronouncing it correctly, but from Estonia. So with the topic Waldur, Ilja has worked as an IT expert in different projects building distributed solutions for the last 20 years. He's the product owner of Waldur.
Okay, thank you. So, a lot has been spoken about LUMI. Waldur is an open source project we started quite many years ago, which was intended to become like a simplification for operators of the HPC center to avoid communicating with people directly. So, and eventually that was actually a good fit. I will talk a bit later about that for LUMI as well, because there are way too many people around LUMI, and without automation, of course, it would be hard. But a bit more about the product. So it's a solution which is completely open source. So we try to maintain the cleanliness of the licenses. It's currently all, it as well as all the components and dependencies are Apache or MIT. So product itself is released as MIT. Its initial usage has been actually as the platform for the government clouds, but we switched to HPC centers quite early on. It's been currently used in several locations. Maybe the most prominent or the most known is the platform for Puhuri, which is used for allocation of LUMI services, but we also run it, for example, as a national platform in Estonia. It's sustainable, so we have a relatively big team around it behind the developments and operations and testing. It has passed several security audits by now. We have essentially two teams behind. One is from University of Tartu, and then there is a separate company, OpenNode. We are working towards opening the governance to make it easier to accept contributions. So hopefully within upcoming half a year or so, this will be more public. But essentially what that does is it allows to set up a sort of mini Amazon for the HPC center, Amazon Web Services, I mean, where you package and broker all the available services that you provide. It can be infrastructure services, can be consultancy services, can be whatever services, into some common framework. You add on top policies, multi-tenancy, cost tracking, and so on, and expose that into user interfaces that, well, users consume, so either web-based or API-based. This is a snapshot I've taken recently. We somewhat recently started collecting telemetry, so we know some of the deployments that are not sharing that. Also, in some more sensitive deployments, the outbound connectivity are not there. It was cool to see that we have deployments where in areas where we really do not do any promotion. But the ones, I don't know if you can show, well, yeah. The ones on top, basically, here, this is also the one that is sharing access to LUMI. So growing gradually based on the metrics. So when and how it makes sense to start using Waldur. So we sort of that as like a GitLab software that everybody is using. It's just that it would be like a GitLab for HPC centers. And essentially, there are two main use cases. If you have a HPC center and you serve your users and have multiple different options from where to get the services, can be in-house HPC systems based on Slurm or OpenStack. It could be something coming from remote locations, for example, public clouds or potentially systems located in other countries. So the whole idea is to sort of consolidate access and to present that to your own users so that it would look like your own solution. Alternative approach is to go with a situation when you have actually a single big service that you want to allocate in many different ways. And this was actually the case for LUMI. And when the project PUHURI was started, which was intended to provide this kind of API that would support multiple models of allocations for different countries in a way that it would still be easy for service provider to provide the service itself, this was a good fit. We also developed an extension for Waldur so that it would be possible to sort of provide that as an end-user facing platform. I mean, PUHURI core is a relatively closed system, but end users are able to use still platforms, and that communication is happening completely transparently for them. So just to give an example, from the Estonian perspective, just at some point in time, we started getting ability to use LUMI, and the fact that it was on-prem but somewhere else is well, concealed from the end user. And we worked actually hard to make sure that there are other solutions, not just Waldur, sort of speaking with Waldur. For example, from day one, Sweden was only using their own portal for allocation of LUMI resources. Also in Denmark, some of the universities are using uCloud to allocate LUMI resources directly. And in some cases, it's just about bash scripts that can do the same. Actually, I was checking that in PUHURI, Waldur has processed around a bit more than 4,000 transactions of different types of creation, termination, changes of limits, and so on over the period of LUMI. So now there is approximately 1,700 or so of allocations running. And the same number, for example, for ETICE, which is the Estonian deployment, it was around 160,000, a bit more, over the last, I think, 5 years or so. And so the idea is that these transactions essentially correspond to, let's say, traditionally user emails or tickets that would otherwise have to be processed more manually. So there is a lot of value in automation. And in Tartu, for example, we have several courses running that depend on the infrastructure provisioning based on ETICE, Kubernetes courses, HPC courses, and so on. So a couple of words about the technical solution. It essentially has 6 main modules in production. So module for defining the access control, team management, role management, permissions. A model that defines how exactly we think about provisioning of the resources, so the life cycle. Several plugins which define how to integrate with a specific technology. So we have Slurm, OpenStack, public clouds, whatever actually. So there is a growing number of modules. There is one thing that typically we see in HPC sites is that you sort of either lack a concept of a service desk or it's maybe based on a slightly legacy technologies. So what we wanted to do is to provide an easy way to integrate existing service desk or something that could be set up as service desk to the for the sites so that users would have a single window of access. So we have support for a number of backend solutions there. Then we have access policies as well as cost policies to allow to sort of provide different delegations of control over what can the users do. So both from the service provider side as well as PIs and so on. So you can kind of let the students go free. And a bit more just technical things about notifications or broadcasts and so on. One thing that we have been working on also within PUHURI project is the application review portal extension. So traditionally the allocation of the resources in the cloud world is done that you click, you get. And because that was also a bit of an inspiration for Waldur, our first approach was to automate as much as possible. So if you request something, you get it as soon as possible. However, in the academic world, allocation of resources often is happening through a review process. So we tried to battle it as long as we could. But eventually, we understood that we need to provide this as an extension on top. So we are sort of in last phases of testing of that and finishing the development with a first release, hopefully coming out, well, Q3 is, let's say, slightly pessimistic, but maybe realistic estimation. So, just a couple of words about the technology. So you see just the standard stuff. So We have a backend, which is mastermind, codenamed, which essentially exposes the API and contains the main logic. We have several user interfaces, so Ansible playbooks and SDK, which are actually producing the majority of our transactions. And then we have human-oriented web interface, codenamed Homeport, which produces majority of our support tickets. And then on the backend, essentially, we have a traditional technologies, so we try to go as standard as possible. So it's Postgre, Celery, RabbitMQ, and so on. In production, we typically deploy Kubernetes. In some test environments, or let's say less HA productions, we have it as Docker Compose as well. So in a very simplified way, essentially, Waldur allows to say how you can get stuff. So this stuff can be an allocation on LUMI, it can be a virtual machine, it can be a request for consultancy, and the way how it's implemented, the processing of this execution is actually specific to the technology. So this is something we maintain. As part of the provisioning, there is a possibility for people to start using that. And in many cases, we need to expose personal information to the service providers about the people who might start using that. So all this exposure information or concealing of the information, fully GDPR compliant, of course, is part of the process. So just to demonstrate how approximately it couldn't work for the allocation within Slurm. So whenever somebody requests a resource from Slurm, before the actual allocation starts, there needs to be an approval by the person who has the right to approve. Once this approval is done, also the service provider needs to approve the request. Once this is approved, the plugin starts working to deliver the allocation, and once it's successfully delivered, accounting starts. So this is, let's say, simplified a bit the process. Important to highlight is that these approvals can be automated. They can be made manual, depending on the number of or amount of control you want to have as a system. And we have seen, frankly, from fully manual systems to fully automated ones. Typically, you start with a semi-manual one, and then once you have lots of transactions, you sort of stop checking. So on the UI side, which is actually quite an important aspect, so the usability and everything, we have a web interface intended for onboarding of the users and customers. So it's has been tightly integrated with Microsoft ID, although we have been supporting also traditional IDPs or proxies like Keycloak or, well, basically whatever. So SAML or IDC or LDAP or whatever else is supported. And it also provides a common window of access to help desk and tickets and so on. Important aspect was the delegation of responsibilities. So as the number of users grows, it becomes quite complicated to deal with the requests of the users. So early on, we wanted to have concepts that would allow operators of the system to delegate some decisions to some specific people. So such kind of member management as well as membership management as well as role and permission management is actually quite an important part of Waldur. Quite configurable, I would say. So we switched from static roles like PI or co-PI to more dynamic roles that are defined by their permissions. Unfortunately, in almost every country, the naming of the roles are slightly different. So this was a process to find out a common nomenclature, how to name things. So now we have essentially two types of taxonomies that we switch between. One is more cloud-oriented, where you have owners and customers and organizations, and then you have academic one with PIs and so on. Fortunately, on the backend, it's still the same, so that one is easy. On the resource management side, actually, we try to expose as much as possible, but also considering the cases of especially HPC environments, we have been adding more and more components that make sense for integration of the modern workflows, including CI/CD or so basically we have support for robot accounts, for delegated management of SSH keys, for whatever resource-specific user teams and so on. All of them are relatively cases, but the thing is that they typically bring lots and lots of transactions. So from Waldur perspective, we see value in the number of transactions, and probably API in the least amount of tickets that the users create. So the more the systems are used, and the less people ask, the better for us. As I mentioned, Service Desk is an important part. We have integrations with Atlassian, with Zammat, with SMAX, and well, cost policies I mentioned before. One integration I would like to highlight, because I think the next speaker will be talking a bit about that. Open on Demand is a relatively popular product for providing alternative access to the infrastructure. And the problem with that is that if you integrate federated AI and permissions, it becomes a bit of a custom solution each time how to make it work. And because we have several deployments where Waldur is running next to Open on Demand, we have developed a relatively simple, like not too many boxes, integrations that allow to set up a fully blown HPC center actually with very little effort. So Open on Demand is a cool tool, but it really needs some love to make it work. So we hope that this thing will survive, because it took us a lot of effort actually to get it working. Okay, I think I'm out of time. If anybody has questions, so we have quite a lot of documentation online, but if any questions, I'm here. Thank you.
So, questions from the audience? If not, then thank you, Ilja. And I would like to welcome Henrik Nortamo from CSC Finland with the topic of LUMI web interface, continuing with the Open on Demand. Henrik is an HPC specialist maintaining and developing the supercomputing environment and web interfaces for the Finnish national clusters and the LUMI supercomputer.
Okay, perfect. So today you've heard the LUMI web interface mentioned a couple of times. You heard Open on Demand mentioned a couple of times. And now I'm essentially going to give you the 15-minute rundown on what it is, what it enables, and where we actually would like to take it. And I mean, as the naming would imply, is that it's a way of accessing the LUMI supercomputer using your web browser. And it's not meant to replace standard SSH access. That lives alongside power users. If you want to do scripting or whatever, Shell is still the way to go for that. And the focus really lies on interactive and graphical usage for now. We have visions for extending that one. And as I will be interchangeably using the words Open on Demand and web interface, because that's the framework which the whole thing is based on. If you do happen to have a LUMI account, log in. It doesn't work very well on your mobile phone, but it does work, and you can actually get a shell and launch a job if you want to do that. So in short, what you're able to do there is browse, edit, upload, download your files. You can get the terminal. You can launch a desktop. I'll be going through some of these features in a bit more detail in just a minute. You can get accelerated graphics for your rendering, or if you want to interactively rotate some very large models and the CPU doesn't cut it. Notebooks, these were already shown in a previous presentation. Tensor board for following your AI stuff. Development environment, specific applications. One cool thing which is coming, which is not in production yet, is the ability to interact with the LUMI object storage, also in a graphical manner, which we hope will increase the usage there. And as a technical side note, this is kind of a very thin shim. In the background, it's still just Slurm jobs and then some plumbing to make sure that your browser gets to see what's running on the nodes. Okay, so file access, as it states, you can view your files, you can upload and download small files. We essentially have a 10 gigabyte limit, otherwise you're going to exhaust the resources, but for a lot of people that's already nice. They run some simulation, but they can just use their browser to check their results, or if they're generating PNG images, okay, it looks like it's doing fine. For example, they're on the go, they only have their phone, okay, they can still check, okay, my simulation is still running, I don't need to go and phone my PhD students to go and save it. And then we generate, these kind of easy to use shortcuts to your projects and whatever other important folders you want to quickly access. Then you get the shell access. So, essentially the exact same shell that you get from SSH. Your font might be a bit different. We provide it in two variants. So the kind of login shell, and this is as unstable as your normal login shell. So if you lose internet connectivity, then okay, that was game over for your session, please log in again. But we also provide a more persistent variant where it's actually running in a job, and then even if you close down the computer, close down the session or lose connectivity on the train, you can just reconnect and all your work is there. It's essentially just running tmux, but the customer doesn't know it. And we've noticed that the shell, while identical to the shell you get on SSH, it's really useful for new users who've never actually used SSH, and specifically for courses, because then you can drop the first 30, 45 minutes of figuring out, okay, they have Windows and they have Mac, okay, they have no idea how to configure the keys, and oh, now the department security is having some issues here. Just, do you have a working browser? You probably do. Perfect. Now you can just start with the actual things. So how it then actually works for most of the applications, I'm using Jupyter as an example here. So we present you just with a selection, auto-generated that, okay, you have these projects, please select one of them. Where do you want to run? Do you want to run with a GPU or a CPU, and how much time do you need? And these are also dynamic in the way that we stop you from doing silly mistakes. Then there's the application-specific selections. Okay, what Python do you want to use? Do you want to use something we've pre-installed, or are you an expert and you've already configured your favorite ML environment? Okay, select that one and we'll just do it for you. And then essentially just it'll go in the queue. Once it's running, then you'll get a button, okay, show me, and then you'll get the same UI as you would doing in manual SSH tunnel. You just didn't have to do the work. It's less error prone. You don't have to keep the connection up. And of course, for people who've never used SSH, on LUMI it's quite cool that, okay, here's PyTorch pre-installed, here's a node with 8 of the most powerful GPUs and 500 gigabytes of RAM. You click start and you start doing. You don't need to know what the machine is doing or how Slurm works, or at some point people even get confused on what machines they are. They just click in with their password and okay, I'm running somewhere and it works. I don't care by the name of the machine. The other feature we've put in a lot of work is this, not feature complete, but I would say working Linux desktop, then just running on a compute node on LUMI. And the idea is there that you can kind of, the workflow people are used to on their laptop, you can kind of bring it to the supercomputer. Of course, you don't have insane resources on the desktop itself, but from there you can orchestrate further work, look at your results again with an image browser, a PDF browser, even if you generate videos, or if you have some kind of data sets which requires you to manually open a browser and click and download, then you can have them running there. So then you don't have to transfer them via your laptop. And then we've done a lot of work to enable that if you run the desktop on a on the LUMI-D visualization GPUs, then we actually accelerate those for you. Because then if you're running a CPU-only desktop, then, for example, if you have a very large, I don't know, engineering model of a car or some fluid dynamics, actually then interactively rotating is okay, rotate, wait 20 seconds for the thing to render, and then do that again. And the idea being there that people are able to customize this. They want a shortcut for their favorite application, shortcut for their favorite files, and they can do it, and it's persistent, trying to play into the logic they're familiar with. So, as I said, it's based on the Open On-Demand framework, and we've done quite a few customization, but nothing massive, and we haven't touched kind of the core Open On-Demand. We've just done things on top of it. So one of the largest thing is these dynamic forms, which automatically you don't have to type in your project. We know what project you're allowed to run with, and we know where they're allowed to run. So then if you select that project, then we know, okay, this is a consortium project, then we only show you the consortium partition and vice versa. And then we also know what's the maximum runtime or maximum amount of resources. And then if you happen to have a reservation, you don't need to dig it up, you don't need to remember, we just show you, hey, by the way, we noticed you have a reservation, you want to use it. We've done a lot of work on the dashboard, so that would be the front page where you actually log in to show you how's the system doing, is it occupied, and then show you these kind of early warnings that you're running out of file quota, or your project is nearing its end date, or hey, one of your project actually closed, you should probably be aware of this. And again, the object storage integration, which is coming soon, hopefully this month, but maybe next month. So is anyone actually using this? That's a good question. We put it in a lot of work. So we opened this about 5-6 months ago in November. That's the very large peak when people went, hey, this is something new, and then they crashed it because it was too many people, but now it's can again handle that many people. So currently we're seeing maybe about 70 to 80 unique daily users which actually authenticate to the web interface, and they submit anywhere from 30 to 80 actual jobs. Then they do a lot of things just in the web interface and not which do not go with jobs. Then during courses, we might see then 60 concurrent users plus the normal usage going up to 400-500 course. And as a comparison, we have this also on the Finnish national systems, where we've run it for now, I think, 2.5 years. And there we have approximately 600 monthly users unique, just submitting jobs via the web interface, which roughly corresponds to 50%, over half of the user base. So LUMI is, yes, a tier 0 machine, so it doesn't have as many of these really, let's say, beginner users, but I do think there is an upwards going trend there on that one. And just as out of a curiosity, so the top 5 is displayed there of usage. Finland is, I mean, currently #1 because we've developed the thing, and then people are used to it on the national machine, so then they jump. And I probably, if other then European countries introduce open and man on their national system, they'll probably be pretty happy jumping onto a similar kind of experience on LUMI also. Okay, so shortly about how we've designed the thing and what's the focus there. So #1 has been kind of ease of use. Anything we can hide from the user or automate or things which they do not care about should be done, because essentially they want to get launched into their application and start doing the things that we don't know about, but they are experts on. They don't want to fight with the system, fight with the queues, or see how you do that. We put a lot of focus in it being beginner friendly, so that even if you don't have a experience in HPC or even an experience in Linux, things should still be relatively intuitive how you get started. There was a question previously on managing kind of the usage of the large supercomputers that you have quick queues but maximum utilization. So one thing, of course, what the web interface allows us to do is have much more targeted limitations. So we know that if we give you this application, we'll limit you to, let's say, 2 GPUs. And you can even ask for more, because we know there's no point, because you won't be able to saturate 3, or then limiting the runtime, so it's more kind of sensible, and it keeps this interactivity. We're not a very large team. I have a slide on that one. So it's been designed from the start to be extendable. So we build the thin interface and the scaffolding, and then all the other people working with LUMI, supporting LUMI, can then build the actual applications or set more features there. And we heavily upstream everything to Ohio Supercomputing Center whenever we can. We believe it's good to contribute there. It also makes it much easier for us in maintaining the whole thing, and they've been very receptive. If you're working on Open On Demand, I encourage you to also get in touch with them. They're very helpful. So the main maybe missing feature if you were really quick at looking at the listing was you can't submit jobs. You can submit the normal batch jobs to the web interface because we felt that the feature wasn't really up to par. There were no features to stop the users from doing dumb mistakes. And then it's okay. Then they can just go edit the file on the command line. So that's something we would like to see. Then more and more compute is going towards this workflow, not just one single large job, but many small jobs with interdependencies. So then having a graphical interface of seeing what they're doing or stopping them would be very nice. More system and job information. Okay, in my dream, I could show, let's say, the GPU utilization for their jobs when they go into the web interface, and okay, that job was bad with using the GPU, I should fix it. And then some more kind of domain-specific functionality. Can we create a richer ecosystem for people doing AI or quantum stuff or geoinformatics? Main challenge is, of course, finding something which is kind of worthwhile the investment, that you don't just do something for a single person, you do it for a whole user group. Okay, so very quickly about the deployment. So essentially it's a 3-tiered deal that on the bottom is kind of the most important people is the LUMI admins. They maintain, of course, LUMI, as the name implies, they maintain the containers where we deploy open on demand, and they manage the core open on demand because that's kind of security critical. Then the team I'm in, we take care of the actual application, the CSC customization, and then the idea is anyone above that, be it LUMI user support, local organizations, or normal users, the tech wizard in a specific research group can then actually just install software which is used via the web interface. So we've spent very much time on the proper productization of the actual deployment, mainly also due to the fact that we deploy this onto other national systems, so we're maintaining it live on 3 systems simultaneously. And essentially we have this full testing pipeline where first we validate, we develop new features, then we test them internally, then we deploy them to a almost identical setup of the production, and then we're satisfied, then we actually push it to a release. Releases are unfortunately not zero downtime, but again, we're operating on LUMI, which also has downtime from some time to time, so users are pretty accepting when we inform that, hey, we're going to be down for 10 minutes instead of, hey, the file system is going to be down for a week, so it's kind of fine. We try to open source as much as possible. We have some stuff under the CSC GitHub, you can go check it out. Not everything is there, it's a work in progress, cleaning it up and pushing it out in a form which is actually then useful for someone. Thanks for your time. If you need more information, go check out the web interface, check out the documentation, or grab me by the arm after the talk. Thanks.
Thank you, Henrik. So, are there questions from the audience?
Thank you very much for your informative talk. My question about users who intend to use both possibilities, to shell submission and open on demand your submission. Maybe you ask them for which problems they think that shell version is better and why they are not fully moving to your new approach.
Yeah, I think there is, because currently we don't have that many features which are super useful for power users. So if you already know what you're doing, yes, getting a Jupyter notebooks is, even if I've used HPC for like 7 years, it's still a pain in the ass to do the forwarding. But that's also something I would like to develop and go speak to the guys running really large things. What would you like to see? Would you like to get more information on what the system is doing, on what your jobs is doing? Again, in my pipe dream with infinite resources, kind of, okay, enable like performance profiling for this job, and then just, yeah, you take care of the job, but I insert a bunch of hooks to spit you out what your GPU or CPU is doing, and again, you don't need to care. That would be a nice feature.
More questions? In case not, then thank you, Henrik. And last but not least, I would welcome Emmanuel Ory from CSC Finland with the topic of EPICURE project. Emmanuel leads the distributed LUMI user support team and coordinates the EPICURE EuroHPC JU project.
Thank you, Heidi. All right. Well, I have the privilege, actually, today to, for the first time publicly, to speak about EPICURE. EPICURE is a EuroHPC JU project, which just started. Actually, the kickoff was mid-February in Portugal at our partner location in Estec. But I wanted to speak maybe more why the need for such a project in the European HPC world. Starting from the LUMI user support team model, because I am lucky enough actually to lead the activities of this team. So first, in a nutshell, so what is this LUMI user support team model? So it has been quite repeated over time these last 2 days. So LUMI is a consortium of 11 countries together with EuroHPC JU. And it has been decided to have a centralized virtual help desk, which is run by a distributed network of HPC experts. And each of the consortium country is providing 1 FTE for this team for the duration of the LUMI operations. The main activities of this LUMI user support team actually is based on L1 and L2 support with a help desk, which actually basically takes almost 50% of our time. Beside this help desk, there is the user documentation or LUMI docs, the management of the computing environment, or the software stack, which is essentially based on the EasyBuild, but also SPAC, user training and hackathons, and as well as some L3 support together with our vendors, HP and AMD. But all of these activities actually are done essentially in collaboration with all these partners. First of all, of course, CSC, as it is the hosting organization, but also EuroCC2 and the partners of the consortium. So from there, what is missing actually to ideally help all the users in Europe? So first of all, of course, naturally, the user support team is dedicated only on the single system, LUMI. Second of all, we are lacking resources for especially L2, L3 support, because we need actually the assistance of the vendors for that matter. So first of all, before the project, so how did it mature? We are lucky enough actually to have in this EPICURE project all the existing hosting entities of EuroHPC JU plus the 2 future exascale systems. Actually, I will jump to this slide. You can see here the EPICURE consortium. So 5 partners working on LUMI. The 2 other pre-exascale computers from BSC and Cineca, all the petascale computers from EuroHPC JU, and the 2 future exascale systems from Jülich and Gensi. This project aims to be dynamic, meaning that the new systems coming in the next 4 years will be integrated within EPICURE. So it aims basically for establishment and 4-year operation of a LUMI user support team model, but aiming essentially at level 2 and level 3 support. However, even though we just started the project, we already need to think, what we would like to achieve and how to continue after EPICURE. So it would motivate us how to start now EPICURE. And providing that it is successful, this model is meant to remain operational. Of course, there will be some changes over 4 years. If we take 4 years ago, no one or maybe very few people would have the idea of what the HPC ecosystem would be in Europe today. In 4 years, it will change drastically, most probably. And how do we cope with that? We have to adapt. And this is both in the LUMI user support team and it will be in EPICURE. The users are changing, their competencies are developing, and very quickly. We were speaking, actually, there were very interesting discussions this morning about the training. And I found it actually, I realized I found it a bit strange that we call the the students we are hiring for summer trainings, because actually now it's a two-way coupling. We are training them, but they are also training us, because they have the knowledge today. If I take the example of the master from EuroHPC, I met them in Antwerp. I was extremely happily surprised. I mean, how competent they are, and we will fight, I mean, to hire them. So more in practice, actually, so the objectives and the activities of EPICURE. So basically, porting and optimization, code enabling, scaling, performance analysis and benchmarking, code refactoring, most probably, and code optimization. This is the core, actually, of EPICURE, the technical work. There are 2 work packages dedicated to this activity. But there is also one web package dedicated to training, because we would like, of course, within 4 years, to attract new users, a new pool of users. And this training would be open to anyone in Europe. Also, the drafting of best practice guidelines, which, of course, will be public from the work of EPICURE, and the development of a portal gathering all the information from for the EuroHPC users. Is it working properly? Yeah. Information of the systems offered by the JU, architectures, access mechanisms, and support services available. But also, actually, we need to meet some of the Digital Europe program objectives. Anders mentioned yesterday, of course, Destination Earth program, which some work will most probably be dedicated to these projects. We spoke also for 2 days quite extensively about AI. There are new projects coming for the pre-exascale computers very soon about AI. We can see, I believe, on all our systems, and particularly on LUMI. Today, LUMI G is essentially actually dedicated to AI. Also, I mentioned this EU Master for HPC, and also something Anders mentioned yesterday. We need to provide support to be trained and to provide support to benchmark this new family of European processors. So here is yes, the consortium I already showed. So basically, how in practice users can benefit from EPICURE support. Together with EuroHPC JU, we wanted the procedure to be as seamlessly as possible for the users. So actually, they can request, like they can do today, allocations through the JU portal. There will be a form for extreme scale projects, regular projects, maybe also for development projects. We will see over the operation of EPICURE, where the PI can provide further information on what type of support they need. Is it porting? Is it optimization? What type of code is it? What type of development they would like, etc. Not too long form, but then the support team need to take contact with this PI, and then they start to work together for the benefit of this team. I would like to emphasize on the fact that actually porting and optimization is already covered by a lot of COEs. There is a main difference between EPICURE and the COEs. The EPICURE is only based on users' requests. So the PI need to request an allocation from EuroHPC JU and request assistance from EPICURE. So even though we won't work in the same way, actually we will contact all the COEs to coordinate our work with you. And last but not least, yesterday I noticed that Anders was mentioning the recruitment at EuroHPC JU, and very conveniently, actually, the CSC template is mentioning the open position at CSC. So please feel free to browse. Thank you.
Thank you, Emmanuel. Are there any questions from the audience? If not, then I would like to thank you all the speakers about giving these interesting insights about new developments of HPC.
Thank you very much, Heidi. And now we will move on to new developments in HPC training. And the moderator will be Ilmars Slaidins from Riga Technical University, Latvia.
Thank you. The last presentation was linking to education and training. I'm happy to this because my session is about education and training. And using my opportunity, I will start this presentation with my presentation. So it's funny. So as you see, we have developed HPC Basics course. And that's my presentation here. So there are different courses already. One is developed by PRAISE project. And this is supercomputing course, which you can find as a distance course in Future Learn. And this is developed by Edinburgh University. And another is EduCamo, which is developed as elements of supercomputing from Cotainr University and CSC. And these are two courses which are in the distance format. And so there are many other courses as well. And there is one course which was being developed and initiated by NCC Greece. And there were many countries involved, and Latvia was also involved. And no, this course is existing, but all these courses are in English language. And there are also courses in Sweden and Belgium and Portugal, Spain. Some are in English language, some are in local languages, and so on. And our decision was to design course in HPC Basics in Latvian. So that was our aim from the start of the EuroCC project. And so we started to do this already in 2021. But unfortunately, there were other tasks, and so we were not able to finish this. So we started with two courses. One is like the basics course with 12 hours for those who are not experts in IT field. And this is the task we looked as a promotion of HPC, because in Latvia we are trying to push this information around, but it is not very well working. Somehow people are not knowing what is HPC. Therefore we decided to create such a distance learning course. Another part was practice for those who using Linux and can use this HPC. And this course was like more serious for users, as it was said in previous situations as well, that there are people who would like to use HPC. Two sides. One is just knowledge, another is practical application. And so we started again this work at the end of 2023 on this basic course, because the second part was, let's say, standing still. And now we are close to the finish. And this course is made in the MOOC standard for about 12 hours. And content is combined from ourselves, partly from EduCamo, also from FF for EuroHPC success stories. And it contains 4 parts, and with final part, and altogether we expect that it will be some 12 hours. And here are workers on this, Sabine Upner and Viktor Zagorskis, and me, myself. And so we are now close to the final part of this course development. And here you see the starting page of the course, where are 4 parts. You can't see final part, which is below here. And at the right corner at the top here is mana vide, it is my space. It means that this course is open for all. Everybody can join and learn it by himself or herself. But those who would like to get certificate, they have to go to this mana vide for registering and passing every week some final examination, like a test. So that's our control system. Here you see beginning of the course. At the left side you see all the schedule. In the middle it's the start of the course with all logos of, let's say, financing and so on. So, and here is the content of the course. As I said, it contains 4 parts and the final part. The first week is about why HPC is needed. There are some videos and texts. Then second week is the history of supercomputing. We start with the history from Latvia and other countries and top 500. Then it is what is parallel computing, which is the essence of the supercomputing. We are trying to show how does it work, let's say in creating pizzas, for example, that everybody do something in this. And then we are using HPC success stories, which are published now in FF for EuroHPC, that these people can study these HPCs, success stories, and choose which is the most appropriate for themselves. And then at the very end, there is this final test, and we are looking for response from our students. We are asking to send some response to us, how did they like this course. Every week has videos, texts, and self-evaluating tests, which are available to all. And here you see one of these self-evaluation tests, where the red line shows that it's the wrong answer, the green line shows that it's the right answer, and they can retry this test as well. Try correct answers and so learn by themselves. And if they have a lot of mistakes in these self-evaluation tests, then it means that they simply have to reread materials or once more look at videos and so on. And then at the end of this, we have this final test at every week, as I said. And there are 10 questions, and they have to register in this mana vide, and then they have access to these final tests. And they are successful if they are getting 7 full answers. So it is 70%, and each question has to be fully correctly answered. Partly these questions are coming from these self-evaluation tests, but some are also new. So at first we decided that maybe there will be 3 attempts possible, but now we are opening it for all to use how much it is possible, and let's see how it will work. So here is this mana vide. At the left side you see these tests, and they can return to the course. And here is the one question, the first question from this final week test. Yeah? And here is the question, what is the right translation from the English HPC in Latvian? And it's at the very bottom. Augstas veiktspējas skaitļošana. So we are repeating this term several times in the course to make that knowledge in Latvian, what does it mean. And then they can say that continue turpināt, and they are getting second question, third, and so on. And at the end of the 10 questions, they are getting response, how much questions are answered correctly, but not right answers. Just said that there are mistakes and so on. Then at the end, 4th week, we have these success stories. We combine these success stories in 4 areas. This is here you see two combinations. It is healthcare and another is transportation and building. And there are 8 success stories people have to read. Then they have also these self-evaluation tests. And finally, they have to write down evaluation which were interesting for them, which they can use, and what was the interesting case here. So, well, now I said this course is close to piloting. We still have to develop something for this, but we hope that at the end of this month we will start piloting. But no, we have 3 people just working on this. Let's see how it will go on. After piloting, we will create corrections. Maybe, as I said, maybe we'll allow these final tests in the week. Let's say just 3 times maybe, or let's see how it will work. And of course, we plan to start this course from September, when starts our school year at university. No, let's see how it will go on. But we started already, it was said several times, one project in 2022 with 3 universities developing HPC courses for universities. And in general, we also produced this open platform for access to HPC. So all these measures are directed to create popularity of HPC, to provide training resources, and that's what we are doing, is one step in this. Anyway, education in HPC in Latvia is developing. That is my final thanks to you. Maybe there are questions. If it was all clear, then I have to present next. Next is Mait from Estonia, and he will present HPC courses at the University of Tartu. Please.
So, good evening, everybody. My name is Mait. I'm going to present about the HPC course at the University of Tartu that we piloted last autumn. So, a table of contents about things that I will be talking about. I will talk about why we even started giving the course in the university, how we did it technically, how we set up the topics, then about what we got right and what we got wrong and what we can actually improve on. A little bit about myself as well. I have been working in the University of Tartu HPC Center for 5 years now as a systems administrator. These days, everything related to the cluster operating system and above is my main responsibility, and I manage all of that. So I am very integrated with the topics that we taught, actually. And yeah. So first, we have had a long-standing problem that I believe many of you have faced as well, that the users might not really be interested in HPC trainings. They have their things. They have been working on HPC for a while. They just copy-paste their stuff. It works, and they don't care anymore. So getting them to actually learn how our stuff works has proven to be difficult if they don't have motivation about it. We even found a work group that had like an image of our cluster on their wall taped to it that was like 10 years out of date, basically. So that's when we discovered that we have a serious problem with that. But their things work, they were happy, and that's it. So we figured that we would need to give them motivation to actually attend the training, so some kind of a reward. So we actually created a specific university course. The idea was to get like the students who might be writing their theses and using the HPC cluster to actually learn how to use it. And a lot of our users are PhD students. A lot of them are professors as well. Well, they don't study anymore, they just use the cluster. But they can, in their work groups, they have PhD students, they can send them to the course, they get course points from it, they advance their studies, and at the same time, those same PhD students can go back to their work groups and tell them exactly, like, yeah, this is a better way to do things, let's like switch over to it if they want to. So we basically created an HPC training, which is wrapped inside of an university course. So the course setup, it was 3 points, which is like 84 hours, I think, in total. It lasted the first half of the semester for 8 weeks then. We set up a weekly lecture where we talked about the topic of the week. The topics will be discussed later. And all of the teachers are staff at our own HPC center, so our own system administrators, developers who are specialists in the same topic that we are talking about. The seminars were held on site and remotely, but they were not mandatory in any sense, so they could come and just ask questions about the topic at hand. We didn't give any extra information there unless they wanted to ask. The problem was that if you tell the students that something is not mandatory, then the attendance dropped heavily after that. We decided not to do an exam at the end because the labs themselves are pretty thorough, and if you manage to complete all of them, then in our eyes it was enough. So the technical side, we have quite a bit of expertise from other courses that we're giving. So for example, we have a systems administration course that we also all teach that we have fully automated. So we use scoring checks in Nagios for that. So every user gets an anonymous name, so because they can see everybody else's progress, and with GDPR regulations, they shouldn't be able to see other students' progress. So it has been anonymized. But with every lab or every week, we released new scoring checks. They can go into the scoring site. This is technically what they see. It's very red currently. But once they start doing the actual lab assignments, they start going green one by one. So basically, Nagios uses bash scripts in the background that return a specific return code. And you can tell Nagios, OK, this is red, this is yellow, this is green. And on the right-hand side, you can actually display information that it will return to the student. So we have a potential to make it more explicit to the users what's wrong with their current lab task. For example, if they almost have the right permissions on the directory, if they need to change it, but not exactly, then it can go yellow and say OK, you need to still do a little bit more. And they can go by their own pace. They don't have to ask us to verify whether they've completed the labs. They can just go look at the scoring. If everything is green, then they're done. So there is no teacher input required on that part. So in that sense, it's almost infinitely scalable. We can have hundreds of students if we want to. So it isn't a problem to get more people on board with this. So it doesn't take too much of a teacher's time. So the HPC access, we have our own Waldur setup. So we wanted to use as much of our infrastructure as possible that we already have present, so we don't have to make up new things for it. Well, except Nagios, that we don't use anywhere else. We just use it for the course. So they get an invitation to a project, they have to accept it, and then they get access to the HPC, just exactly like a regular user would. And we had the course documentation in our own documentation website. It's still available publicly, and the students can refer back to it if they actually start working with HPC systems. And we had a separate Slack channel that the teachers are all in there, and the students are all in there. They can just come in and ask questions. And besides the seminars, nobody attended them. Students tend to work at Wednesdays at 12 a.m. or something like that, and then they start bombarding you with questions during that time. But yeah, usually there we would answer their questions, they got their information, and that's that. Worked very nicely. So the course topics. We started them off pretty tamely with the introduction to HPC. We talked about what it is and what it's used for, basically. A general introduction to HPC. This course wasn't really meant to be the whole thing wasn't supposed to be talking about HPC, but how to actually use it. So basically, the first lab was the only part where we talked about the HPC itself. But we made our lives easier. They basically use a shared project directory where all of the course progress is stored. That part is automated. But they have to get familiar with the command line, so we had them create their own like scoring directories and stuff like that. So we didn't have to automate it, and they got their hands warm with the command line. The next one is one that I created using modules and software. So using just module load and running a command is really basic. So I put in spec as well, so they actually got to compile their own packages if they would need to do that in the future. The third was sharing, managing, and transferring data. So that's how they get their data into the cluster, how they get their data out of the cluster, how to do compression, not in parallel, because file systems usually do not like that at all. So yeah, just introducing them to best practices on how to move data around. Then we had running and monitoring jobs. So in the first lab, they also submitted a simple SBatch hello world basic script. So running and monitoring jobs, we went deeper into what you can do with Slurm actually. We also introduced them to our monitoring stacks. So we have Elk, where you can actually go and there's a visual dashboard which displays how much resources your job is actually using. So they can learn about that and how to optimize their jobs. So the fifth one was the description of ETIs. So that's our Waldur instance, introducing them to the different things that we have. So Open On Demand, Jupyter instance, RStudio, stuff like that. So they got to go in and play around with that. Problem with that one was that I actually was working on setting up our own on-demand instance at that time, and I finished it like a week after that lab. So we're a little bit late on that, but we can use it next year or in the coming fall. The sixth one was using containers and environments. They are pretty similar in what they do, so we could combine them really well. They got to use Singularity, they got to use Conda environments, how to build them, Python virtual environments, those are really popular. So they got to play around with that. Now there's this spike in difficulty in that sense. They got parallel computing, so MPI, how InfiniBand works in a general sense. They got to run like parallel programs across nodes. And the eighth is into the GPU computing, so they got to practice with GPUs, run their tensor programs and stuff like that. What we got right, the interest was surprisingly high. We expected like 20 students or so. At first we had 60 to 70, but a lot of them canceled the course at the start, which is okay, but we had 45 participants at the end. Most of them passed. I think there were like 3 who didn't complete the labs by the end. The software and file transfer labs were the most popular that the people enjoyed. The automated progress tracking, students really enjoyed that they could go at their own pace. Some complained that they lost track of time and didn't have time at the end, had to do everything all at once. But I see that as a student problem more than ours. But yeah, they had one deadline, easy. And yeah, they liked the pacing for the most part, which I will talk about in the next slide, which is what we got wrong. The main thing is the last 2 labs. Most of the students are not informatics students. Most of them haven't touched even Python before. They just need to run computational jobs for something. So if you start giving them a Python program that, yeah, run these tensor cores and do this and do that, they have no idea what's going on. Even the informatics students don't know what's going on there. Even we don't really know what's going on there. So that was a huge difficulty spike. So we had to keep motivating the students to actually do the last 2 ones. So yeah, if you have people from the University of Life Sciences who don't do informatics at all, they come in and they have no idea what's going on with like GPUs. They barely know what the GPU is. So. But yeah, that's something to fix. Having different lecturers, well, we had the different specialists give their own lectures, which was in that sense a good thing since all of our administrators got like public speaking experience. It was my first lecture as well that I ever gave, which was really nice. But different people have different styles, and if every week you get information differently, then it might get confusing for the students. Some explain things in more detail, some explain in less detail, and it gets weird at some point. And the checks, well, they're written by us according to the lab guides. So testing them is something that we could do more. So we have had issues where the student has actually completed the lab, but the check shows red and they ask us about it, or they bang their head against the wall and then don't think to ask, and then they come to us 2 weeks later about it. So yeah, there's better work that we can do there. What we can do better? Definitely think about the last 2 labs, how we can. We should probably just give them the programs to run and profile them and see how different things in GPUs or how MPI could help your jobs. The tests could be better always, and we could do more tour lectures. So this time we just in the lectures talked about the topic and all the practical things that they would be doing, but we could go more broadly inside of the lectures. They don't have to remember everything, but the more you give them, the more it sticks, basically, at the end. I think that's it for my slides. Thank you for having me here, and I think I can accept any questions.
So, are there any questions from the public, please?
Thank you for such valuable and practical description of your course. And I myself, I'm currently teaching a course on another topics, but I want to dedicate, I think, 2 lectures on HPC. So what do you think is more important to fit in if I have only 2 lectures, like 2 times 1.5 hours?
I would say one is just to talk about HPC. As we have heard here before as well from different talks, that a lot of people actually do not know about HPC. If I've talked to people, like I'm studying in Tallinn University of Technology right now, talked to a lot of the students, they have never heard of such a thing. A lot of people do not know even that we have supercomputers, national supercomputers basically. So that's something I would focus on. And if HPC is not the main topic of your course, I find that success stories are always nice. You can talk about how Pringles has used like HPC for their airflow simulations and stuff like that. So if you bring out like those fun success stories, then I think students will listen and gain more interest.
So, thank you. Maybe more questions?
Raimond Šegis from Vilnius. My question about how many students in Tartu University are taking full parallel computing course?
I do not know that. We have a separate chair of distributed systems that handles those, but I do not know those statistics sadly. We have some courses about MPI and things like that, but I haven't taken those. But
Any more questions, please? It's interesting that some interesting topics. Thank you. So, next speaker is Stepas Toliautas from Lithuania, and your presentation is expanding training knowledge pool by using NCC collaborations.
Hi everyone. My name is Stepas Toliautas. I represent National HPC Competence Center, or NCC Lithuania, and today I'm going to talk about merits of collaboration for novelty. Collaboration is an important topic and often used term in the network of European HPC competence centers, in EuroHPC for short. And after setting up those centers, the first step was actually to start to provide said competences, and with that to first look at what you already have or can easily access, which is great for large entities, okay for smaller entities, and in a network of over 30 members, you might end up with 30 different offerings on some topics. For example, I know maybe a half dozen MPI message passing interface courses more or less equally available over EuroHPC. On other topics, one finds only a few options or even none. So then the second step is to actually start to collaborate between NCCs, and that can be as simple as inviting an expert or routing your users to them if you know them. But what if you want something new? And here is where active collaboration shines. By pooling expert knowledge and resources, you make things easier for everyone, basically. Larger entities then can spend less time or effort duplicating something. Why start working on some course if friends are already working on the same course? And for smaller entities like Lithuanian NCC, it might be the only way to actually add some topics to their knowledge pool, because, as you may know, some of the smaller NCCs are already stretched person-wise as it is. So let's comment on two recent collaborations by NCC Lithuania that could be in some ways considered new. The first one is a bit vaguely called Best Practices in HPC Training. Never mind the implication that this is the absolute best way to do that. Best practices is another common buzzword in EuroHPC. We can probably meet on this being a good practice on how to do HPC training. It was initially devised in 2002 as the collaboration of ENCCS from Sweden and NCC Lithuania. It was first given as an online presentation in a scientific workshop called HPC for Research and Development, actually hosted by our current host as well. A year later, it was converted into a full online workshop spanning over 2.5 days. It attracted, as you see, over 40 people from over 20 European countries, quite an outreach. And the attendance split, as you see, it's still majority is academia, but actually the split is 70-30%, and all the other so-called main stakeholder groups of EuroHPC projects, so industry, SME, and public, each of them had at least one representative in the attendance of said course. The material of this workshop, one can broadly split into two parts. So the first part is about facilitation of learning by making your instructions familiar with the principles of learning and some useful teaching concepts that bring out the best of learning from your learners. You can be a brilliant expert on your topic, but for best results, you can still make some steps to share your knowledge in the most accessible way. The second part is an overview of the toolchain currently used and practical tips on how to use that. That ENCCS uses for their own workshop/lesson library, about which my colleague Thor will probably have to say a few words later. This current best practice workshop, it feels somewhat meta in a way, in that if you want, you can give it entirely by explaining how to create and teach the very same workshop. And it's also freely available over GitHub. So, since it's freely available, alternatively, if this is not what you need, you can take the material. You can translate it to your local language if you wish so. You can replace ENCCS tools and links with yours. You can even add locally relevant chapters if you want. And in this way, it's easily fine-tunable to actual your audience. This so the last iteration of the workshop of the last autumn, as you see, it was more or less universally positively accepted. It got universally positive feedback, with some comments actually suggesting or asking for more outreach, more people to know this, to take the course and to know about these principles. This is one of the reasons why there are at least preliminary plans to hold another iteration of this course this fall, maybe in October. Again, likely slightly evolved version, because from the first iteration to the second iteration, we were joined by Castiel, the supporting project of EuroHPC, and now there is also interest of some new members that will probably add something of those as well. That's actually another good thing about making actively collaborative development, because as long as there are interested people, interested users, the content, the material itself stays up to date forever. And also this and other concepts outlined in this very workshop were actually used to create a second workshop that I now will discuss, namely one of the GPU programming overview called GPU programming, why, when, and how. 3 questions. This was held last spring/early summer as an online workshop plus bring your own code hackathon over 3 days. It was also online. As you see, it got over 60 registrations from 4 Nordic countries this time. The splits were similar as for the previous workshop. So again, 70-30, but every main group of users represented in the workshop. And the material for this course was provided and presented as well by multiple experts on various GPU topics from Sweden, Finland, Norway, Denmark, and Lithuania. The core of this workshop is set to try and answer all 3 of the stated questions. So why, when, and how one should or could use the GPU programming, GPU computing possibilities for their tasks. It can motivate people to take up GPU programming. So I was thinking whether I should pivot, and now maybe I should. And also to ease people into helping orient themselves in a plethora of frameworks and techniques actually used currently for GPU programming. Decision makers, such as team leads, institution leads, even public agents, can find out some opportunities and potentials of using the GPUs, while the developers themselves are given enough to lead them into quickly becoming productive GPU programmers, without necessarily binding them to a specific technology, which may not even be their own choice. So in a way, those 2 questions are connected. Suppose that you are the leader of some doctoral group, and you are thinking about going to use GPUs for your scientific code. So are you going to send your PhDs to 10 different workshops, or maybe it is a way for you to get familiar with what works and how, and then to choose the best way that would work with your own pre-existing experience and skills and equipment. In the end, different audiences may benefit from different competences and may even acquire them later and elsewhere. But the main goal of this workshop is to get them all speaking on the same terms and to understand each other. And for that, actually, the material of the workshop itself has a bit of range in both scope and depth. If you see the image titles on the right, you can see that at least the middle one is probably much more either narrow or technically inclined than the first one. What are GPUs good for? Well, heating the earth, but also some computations as well. And how did it go? So I would consider that workshop to be a success in both anticipation and results. So first, we were actually anxious about being able to accommodate all registrations. I admit I don't remember how that ended, whether there were some users left out to wait for the second iteration. In any case, as the material is again freely available, it could be at least reviewed individually by yourself on your own pace. And this is what happened in a way. It actually got viral via Hacker News for a few days after the event. And even if I wouldn't call the 10,000 people that view that our learners, they were at least interested persons. I'm also not saying that you should avoid and get rid of the lecturers altogether, because this is what some of the comments are also not saying. you need the expertise to actually teach or explain some things to you. Okay. Also, afterwards, the knowledge, the material of this workshop has already gotten back into where it partially came from. For example, it was repurposed and reused for the 2 parallel computing courses at the Faculty of Physics at the Vilnius University. So, if you decide to move to Lithuania and enroll to one of the courses, you're welcome to do that in the fall. It was also used for CNC's own training. In the future, there are plans to offer material as the accessible white paper on GPU programming overview, and or maybe a massively online course. I will conclude this talk by repeating one note that I think is important. This was actually not likely to be accomplished in a way it was in the time it took with an input of only one NCC or a couple of members. We had all the parts that we needed spread over, basically, but just by active collaboration, we brought them together. So, thank you.
So, thank you. Thank you. Very interesting talk. It's working, I hope. Well, are there any questions? Please. Yeah. We have some, but not no, it is like local training, I guess, yeah. Okay. Thank you for presentation, but there was another author of this presentation as well. It's Thor, who will come to the next presentation. Please. And Thor will present us Training Triumph, Minimizing Impact with External Domain Experts. Please.
Thank you very much. Okay. So this talk, my talk now, is a little bit back-to-back with Stepas's talk. We have been collaborating over the past few years, and it's been very fruitful, very fun, and impactful, I would say. So the theme is the same now. What are the benefits of collaborating on training across borders and across NCCs within the EuroHPC network and wider? And as we will see with the centers of excellence in the EuroHPC ecosystem. So training triumphs, maximizing impact with external domain experts. I apologize for this slide being, or this map being slightly out of date. I think this is for the EuroHPC 1 project. Anyway, you've heard about EuroHPC already. 32 countries now, I think, bringing together expertise, increasing national strengths in HPC, high-performance data analytics, AI, quantum computing, a one-stop shop for HPC. And just quickly about our center in Sweden, we decided to call ourselves ENCCS, EuroHPC National Competence Center Sweden. Our slogan is that we empower Swedish industry, academia, and the public sector to leverage HPC, AI, HPDA, QC efficiently and effectively. And we have 3 sort of activity pillars, helping users get access to HPC, in particular EuroHPC machines, training, the topic here today, and support, HPC support, through proof of concept projects or just some sort of consulting sessions. Castiel hasn't really been explained very much so far, so a few words about it. It's also relevant for a topic I'll come back to later. Castiel is the coordination and support action for EuroHPC. They have different working groups on different themes, including training, but also on industry interaction, business development, awareness creation, and so on. And Castiel coordinates all kinds of collaborations between NCCs and pairs them up and twins them up and creates mentoring relationships between NCCs. So they're often useful to work with. And another type of creature in the EuroHPC sphere are the COEs, which you heard quick pitches about yesterday. The centers of excellence cover a very broad range of topics, domains, including engineering, fluid dynamics, environmental science, and so on. You see the full list there. And you see a collection of logos here in the top right corner. This is not logos for all of the COEs, but the ones that we have worked with or are currently working with on training. So there's a huge pool of expertise in the COE world. How do we tap into it? How do we bring that competence, those skills, to our end users, which are HPC users, our target groups? So we have developed this training event as a service type of approach to these collaborations. ENCCS, we do all the practical work around a training event. We set up event pages, registration forms. We disseminate through all our channels. We take care of getting access to our EuroHPC machine for the hands-on tutorials that should be included in any training event. We also provide a template for the training material to be composed in, as Stepas already mentioned. Our training material is online, it's on GitHub, it has a nice looking modern look and feel. So we suggest this to the COEs, and they often happily comply with this template and use it for the training. We can give them support in developing the training material, just how whatever, port PowerPoint slides to RST or Markdown or whatever. What do we do more? So we host the material, we communicate with participants, we have HPC onboarding sessions ahead of the training events so that everyone is ready to go when the event starts. We facilitate during the workshop. We provide moderation, provide the cohesive feeling. We don't use chat as such. We use a shared workshop document where everyone can write down their questions on the fly during the workshop, so that and there is always someone who follows this online document to answer questions on the fly. So there's interactivity. We take care of, we do the post-workshop survey, and we bring the whole workshop format. What do the COEs bring? It sounds very little, but actually it's a lot of work, obviously. They bring their experts who develop the material, and they teach the workshop. And this is a win-win. We bring in expertise from the COE, we deliver it to our target audience, and the COE gets to provide training that they anyways probably wanted to do, but they can do it easier now with our help, and they can hopefully do it even better than they would have otherwise. Stepas already mentioned this, the best practices in HPC training. So even the COE experts need to practice their teaching, and we had, well, Stepas told you all about it. The purpose of this workshop is to empower experts, give them higher confidence in teaching interactive workshops online and in person, and to be familiar with some pedagogical concepts and scientific findings about how people learn. And yes, a few best practices in how to teach in an effective way. Okay, so we have been working with the COEs throughout the years to give training workshops. Other NCCs have done similar things as we. It has more or less been rather disconnected. Why, I mean, and that's a little bit unfair perhaps. I mean, not all NCCs are well connected with the COE. So we thought, let's bring in Castiel and have it as a EuroCC-wide umbrella concept for all the NCCs and all the COE. So Castiel is now coordinating the COE training spring, where groups of NCCs, volunteers, work together with a given COE, who bring in the domain expertise. And the underlying idea here is to increase the overall number of workshops, to increase their visibility across Europe. We will have a central web page for this. Larger reach across Europe. Even the smaller NCCs that have not been able to work with COE so far, they can get involved, and they can sort of advertise these events to their HPC users in their countries, and bring good training practices across the COE and EuroCC networks. So stay tuned, there will be more information on the training spring. Just to mention that we also work with others, not only COEs. A very nice success story from last autumn was a collaboration with WACT, the Wallenberg Center for Quantum Technologies in Sweden, and NordicQuest, the NAKE project. So they brought in the expertise, and we organized a hybrid event, 40 on-site participants in Gothenburg, who got to see a quantum computer live and so on. Lots of nice social events there. And 40 online. Speakers from both industry and academia. Very interesting talks from the financial sector and so on. And we got to do hands-on exercises on Helmi, the Finnish quantum computer. And that was the first time ever that Helmi is used outside of Finland. Again, the training material is public and freely available online. Okay, so I've been mentioning the training material, and Stepas mentioned it too. We have a library now of 28 public and open source training lessons, which are not just slides, they are tutorials, they have lots of text, they have exercises, code examples, images, equations, whatever you need. And we record these workshops as well, most of them. And by now we have 600 YouTube subscribers, over 1,500 people trained in these workshops, out of which 10, maybe 15% have been from industry. But I would like to correct myself. We haven't really only trained 1,500 people. We publish these training lessons online, and people can browse them at their own pace to learn by themselves. And I would like to claim instead that we have trained thousands of people, maybe tens of thousands. And just as an example, here is the website traffic of this GPU programming training material that Stepas told you all about, just for the past month. So on a regular weekday, around 100 people access this material and do whoever knows what with it. So that's pretty cool. Okay, that's all from me. Thank you.
Thank you. Interesting talk. Please, questions?
Giving questions because interesting for me and for audience. I am lacking a little bit information about broader sense textbooks. You are recommending some for deeper analysis. It is expected to get information from you. What I need to study later if I would like to get deeper information?
Sorry, can you specify a little? So where to go later after having attended?
Finding some list of textbooks, you assume they are best if you would like to study more deeply.
Well, yeah. Well, typically we include some recommended further reading and where to go from here sections. So of course our training event, these are short format training events, 2, 3, 4 So 2, 3, 4 days, often half days, because you cannot sit in a Zoom room for 8 hours per day. So they're necessarily very short, very to the point, very skills oriented. They're not like a university course where you can delve into theory and understand things on a very deep level. So these are focused on skills and they're concrete, hands-on. But we do recommend articles, YouTube videos, books, that people can go to, refer to for more in-detail material, if that was your question. Yeah.
So, thank you. Any more questions, please? Yeah, it's not like university teaching, I agree. Okay, thank you. And we have next presentation, which is more university-like. It is innovative initiative to advancing HPC education and training in Europe, EU Master HPC. So, who is presenting?
Professor Pascal.
Okay, there are two presenters. So Professor Bowie, yeah?
Thank you.
Please.
Okay, so it's really my pleasure to be here. So first time in Riga, first time in Baltic countries. I'm very excited, and I see that there is a lot of activities around, so I'm really looking for partnerships. So as we've been saying and keep repeating, we need talent. So we need the right people to be able to use the machine, to build the next generation of machines. And thanks to EuroHPC JU, we're also very ambitious because we really like to go full stack. So from the processor to the application. So at the level of the EU Master for HPC, so which is funded by the JU, so we try to be a bit quite very large and having most of the countries. And again, I'm pointing that I'm still missing Estonia, Latvia, Lithuania to join. So that's yes, a call for you. Then I would like to also mention that we are having this incredible challenge because at this stage we miss people not only in HPC, we miss people in engineering, we miss people in science. So it's up also to our duties to go to secondary schools, to go to primary schools, to tell our children also how science, engineering, mathematics can be fun and interesting. I really enjoyed the speech of Koen de Bocher in Antwerp during the EuroHPC summit. He was mentioning that at the level of the universities, we educate, we don't train. So the idea is that we are really trying to put the right mindset, the right methodologies, the critical thinking also in terms of the knowledge that we like to bring to our students. But at the same time, we don't want also people to spend ages after that to train when the people are going out. So I think it's very important also to work not only between academics, but to open the door, work with the industry, work with the supercomputing center. So that's what we have been trying to do in the EU Master for HPC. So looking at collecting what would be the necessary skills on the market, thinking what these skills would correspond to the learning outcome, and after that, mapping this learning outcome on courses. So it's a really a pilot program. So we've 8 awarding universities that we've been starting with. So you have here the list: Luxembourg, Thor in Germany, KTH, Polytechnic of Milan, Sorbonne, University of Polytechnic of Catalonia, UZI, University of Sofia. So these 8 ones have been selected to be also spread across Europe, but also with different maturity in terms of HPC. Some of them already got existing master in HPC before the start, talking about Thor, KTH, Sorbonne, UPC, UZI, and then we got Polytechnic of Milan that was just starting a new master in the field, and Sofia and Luxembourg who just joined the fact of building this. So we've been also in this session thinking about, okay, what is the necessary knowledge for HPC? And unfortunately, we've not been as far as other fields. I'm thinking about, there is some books on body of knowledge for software engineering. We need to have something similar for HPC. So what basically is necessary to be called somebody mastering HPC? And so we've been working on this, defining the content, and after that also working on basically turning that into courses, but also checking how we can have the people interact between industry, supercomputing center, and academics. So we've been defining at this stage the program into 2 years. So it's a 120 CTS master, full-fledged. The first year is really about the so-called fundamentals: mathematics, statistics, software engineering, parallel computing, computer architecture. What I did not mention in this slide is that we have also some balancing modules before, because we want not only to be able to bring in people having a bachelor in computer science, but other people having bachelor in engineering or science, already having some lectures in computer science, but maybe missing some, so that they could go on board, and also showing to our people in computer science the interest of the other sciences and the applications that we could have. Then we have the second year with the specializations. So I said here, domain expert, numerical data specialist for science, performance analysis and advisor, system development and support, and system architect. So these specializations are not deployed in all the countries. They are mapped on basically the different countries and what they would like to focus on. Just to give you an example, you know that UPC is very, let's say, active in RISC-V. So they are also working on this system architect kind of specialization, while Thor is more on the engineering side and working on the specialization on numerical data specialist for science domains, for instance. Last but not least, we have internship. What is also very interesting here is that we've been learning a lot, because in everybody's mind we have these terms, and these terms might have something different notion in different countries. So when we say internship in one country, it's not an internship in another country. How to have the master thesis versus the internship, how to integrate this together and so on. So there has been a lot of learning done by the consortium that we can also help spreading and working with you. And also how to, for instance, map your existing curricula, your existing courses. I've seen that you've got some. With this learning outcome that we have here, and check what we see the gap analysis and how to move to be compliant to what we be defining together. So the first year in the first university, we got some mobility. Second year in the second university, and you see that aside from, let's say, this classical, let's say, exchange program, we also have some workshops, and we have some challenges. So. I was happy to hear that one of the previous speakers was mentioning that our students were making good ambassadors at the EuroHPC Summit. In fact, they've been working together on a challenge. So it was conjugated gradient implementation. So for everybody, conjugated gradient should be kind of easy, but on different platforms, including FPGA. So I think it was one of the first, let's say, big usage of the FPGA available on the EuroHPC, let's say, machines. So that was also very special because it was not all the students from one university working together. The students from the different university working, using, let's say, on one hand, new advanced technologies for working together, but also meeting and seeing each other. So it's a lot of networking is done between our students, the industry, the community. Just to show a bit all the effort in terms of dual diploma agreement that we've been working on between the different universities. So now we have some kind of standard templates and way to work on that I will be also very happy to share. So that's now a slide on the different modules that we have in the first year and the second year. What is also important to mention is that there is also some work on transversal skills, how to make a project management, how to think in terms of being inclusive in terms of for the projects, and so on. Yeah. Last but not least, so we've been working also on some additional, let's say, content on the MOOCs, for instance. So now if you go for the EU Master for HPC, you have a website. You can have also access to the MOOCs. So that's something also that the master project is bringing on. Student mobility is really key. So with the internship, with the summer school, I'd like to announce also there is this summer school in Ostrava from August 18 to 24. So if you go again on the website, you have a list, a contact point to register or to have more information for this. So with the workshops could be again opportunity, for instance, to meet the industry, showing about the open jobs or the opportunities. There were specific workshops, for instance, on quantum. There were specific workshops on the local job market and so on. And then we also, as I mentioned, present on different conferences and events. Teacher mobility. So again, if we are working together in this kind of consortium, we are talking about student exchange, but we can also talk about staff exchange. So now what's next, the way I see it is that, so we've been designing this to be scalable so that we could also bring in new partners. We could have stronger links like a joint diploma between a subset of universities. So there are Erasmus calls, for instance, going in that direction. But we could also have universities saying, okay, I'd just like to build my local degree and have some input from what has been designed there, or also partial implementation. When I talk about partial implementation, I'm also thinking about, for instance, degrees in computational science that would like to integrate part of the courses into their programs, or also maybe, I don't know, electronics degree that would like also to take advantage of this. So it's an ongoing effort. So we are currently looking for bright students for the third cohort. We, of course, keep always also refreshing a bit the industry needs. And we like also to work together on how to make HPC very exciting and bring new, young and bright people on board. So now I will let Matthias Brust, Dr. Matthias Brust, present the next project. Thank you. Thank you.
Thank you, Pascal. I think if there are questions, we can continue with the questioning like after my small presentation of more or less 5 minutes. Following up on the EU Master for HPC, I also would like to introduce and to describe 2 additional HPC training initiatives. One is HPC SPECTRA, and the other one is HPCTRAIN. HPC SPECTRA aims to develop an EuroHPC training platform for HPC. The idea is, or the vision is, that it is a central place for HPC training services and HPC training material, where you can access and choose which kind of training you would like to have as a user, as an interested user. But this EuroHPC training platform also has some additional features, which I will explain in the next slide, which makes it a little bit more interesting and appealing. Additionally, in order to design and develop the EuroHPC training platform with some high level of quality in mind, HPC SPECTRA is highly involved in, or strongly involved in, the co-organization of the International HPC Summer School in 2024 and in 2025. So the idea is basically to get input of the organization of the International HPC Summer School, and to evaluate, to assess the training which is happening, and to use it as an input in order to improve the design and the quality of the resulting trainings platform. A quick overview, just a list of the consortium and the project teams, mentioning especially that there's a strong connection to HPC SPECTRA to the EU Master for HPC, where basically insights and results gained during the development of the EU Master for HPC and also the execution will influence the design of the EuroHPC training platform. So there's some synergy, so using all available knowledge which is being developed during the development of HPC training initiatives. Here, when I mentioned about a special feature of the EuroHPC training platform, is it is not only a database, but it provides also access to the skills framework, which is basically a standardized HPC body of knowledge, and it is a kind of foundation of the EuroHPC trainings platform, because based on it, certification mechanisms and strategies will be developed, and it provides also a kind of intelligence below the teaching, the training services and training material. Here's an overview of the platform, basically of the HPC SPECTRA framework, where you have the EuroHPC training portal and the certification scheme, which is based on the skills framework, in connection to input from the assessment of the International HPC Summer School. And everything, all entities are working together to build, basically to influence the high quality design of the EuroHPC training portal. Just for your interest, is one important milestone for the HPC SPECTRA roadmap is training platform delivery in December 2024. So that might be interesting to check from time to time the website or the LinkedIn page, so that you see when the training platform will be available. Additionally, or complementary to the HPC SPECTRA, HPCTRAIN focuses on the curation of traineeships, basically to provide a tool of traineeships to where trainees which are interested and also providers can connect to each other. Basically, companies are looking for experts or want to upskill, reskill experts, and they offer this traineeship. And then users or students are interested in learning a certain capacity, certain competence. They can be getting in contact, and there will be a matching. Interesting on HPCTRAIN is that there will be a continuous monitoring of the execution of the traineeship. So it's not just that universities, for example, will get, or companies will get free workforce for some time to solve a small problem, but there will be a continuous monitoring of the quality of it, and will guarantee, hopefully guarantee, that there is the leap between the education to the labor market. That is a goal of to facilitate and to also to guarantee. It is a goal of HPCTRAIN. With this, I would like to thank you, and I'm opening for question, also related to the EU Master for HPC. So Pascal might.
Are there any questions now, please? Please.
Hi. So I've seen that very skilled tree in the HPC certification meetings. So what is your connection with it? Are you following it or providing feedback or actually coordinating the HPC certification effort?
So we are participating, we are monitoring, we are helping, we will be assessing the quality of the International HPC Summer School, giving feedback in form of report to deliver basically high quality data to influence the design of the EuroHPC training platform. So as you saw, there are many partners. Consortium, so each one has some emphasis on certain work packages.
Okay, thanks.
So, many more questions, please. So, I have one. How you are accepting students? Because we are looking that Baltic countries are not included in your program. Maybe our students also from Riga Technical University, Vilnius University can join. What is the prerequisites and previous knowledge needed to go to this master program?
Okay, so the way it's organized, so it's restricted to the participating member state, to the EuroHPC JU, so you are in. So the students need to have a background in science or engineering, so a bachelor in science or engineering. Then we have two committees. One committee which is independent from the people participating the master is led by Professor Kees Vuig from Delft. And then the students are basically ranked, and after that are mapped to the different universities. So they are going for the first year in one of these 8 universities, in the second year is in the second one of these 8 universities.
Okay, thank you. But there's a problem, because in each country there are different study programs and the content. How can you check that they know this previous knowledge? Because sometimes we need some courses which are, let's say, equalizing this knowledge. Are you using such courses, additional courses, before starting your master program?
Yes. So as I mentioned, we have this balancing module, so that some of the students who are missing some of the skills might follow an additional set of lectures at the beginning of the master. But you're very right. It's very difficult to know everything about all the universities and so on. I think that we still have hope to do it in Europe, but I think also that there's not enough children in Europe, so we'll need to bring also people from outside, and it will be even more difficult to assess about the existing skills and so on. So maybe having also in mind future set of tests and so on to check the match could be helpful.
Okay, there is one more question.
Hey, so related to that, what was the competition rate over first two cohorts? The ratio between candidates and accepted persons?
So I don't have the exact numbers, but just to give you an example, for Luxembourg, I opened the third cohort on April 1st. On April 5th, I was saving 300 applicants. And I suppose I will select something like 20 of these 300 applicants. But as I mentioned, many of these applicants are from outside EU, and we don't know exactly what is the level. So it's highly competitive, but I think that if you have a good student from your university, they have true chance also to get in.
Okay, thank you. I hope that our students are listening to you and maybe they can join your program. Thank you.
Thank you.
So I think that by this we are finalizing. I will give my microphone to Eva, please.
Thank you, Ilmars. So lunch break and see you all back at 2:30.